spread of coronavirus disease or COVID-19.
Anyone would like to make comment on this? That which factor should I control for making the try to reach TPD by better technology? Okay, good answer. Replacing combination circuit. Okay, reducing the path delay. Path delay. Okay. Okay. Okay, I think 3-4 answers are good enough, and we can talk further on it. And no one wants to say that TCQ can be increased or decreased, or setup time can be decreased, because there are only 3 factors which you can increase or decrease to control the speed, isn't it? So which one you will increase, decrease? Which one you will decrease, TCQ, TPD, or T setup? I think I want a specific on this, or any other method you would like to do.
TDP, sir.
TPD. Okay, just give me a minute. Yes, TPD is of the higher priority to work on, because remember that setup time and TCQ times are constant, isn't it? The TCQ and T setup are both constant because you are fabricating the flip-flop, and the flip-flop is a component which will always have a constant performance parameters. So for any given technology, we will have TCQ and TPD as the same, isn't it? It's just like a 2-input AND gate. If it has a 2 nanosecond delay, it will always have 2 nanosecond delay. Okay, it will not change that, at least in the same technology. Okay. So working on TPD is the only workable solution. So techniques, I mean, some basic, I will not say that I've covered everything on the grounds of previous high, but yes, you try to keep the logic gate depth as shallow as possible between the flip-flops. You know, you don't try to bring everything inside one flip-flop stage, okay? Then you avoid circuit design that are highly loaded in the clock or critical path. Critical path is the slowest guy on which the system will work, because the gate delay will increase as the capacitor load is increasing. So if it is driving more number of load, so higher the load, higher would be the delay. Okay, and then you always duplicate the logic to reduce the fan out, which will always impact on your the speed or the performance of the circuit. Okay, then you can always pipeline the logic to increase throughput at the expense of latency, but that's a good idea to do that, and that's always good. This okay. clock speed, yes, can we go more on it? But actually not, because many people say that, ask me this question, that these days the products which are available at the speed of 2 gigahertz, but the 2 gigahertz is stable from last few years. So we have not yet seen an progressive trend in the clock speed, that 2 gigahertz and 2.5 and 3, 3.5, 4, 4.5, 5 gigahertz, 6 gigahertz, 10 gigahertz, something like this we are expecting. No, uh, there has been, the clock speed has reached to such a level that really, making the clock speed faster than this level would require huge amount of challenges. Okay, and that is not required as of such now. It is not required because with the size of the transistors, they are so small that instead of one core of the CPU, you can put two cores, both working at 2 gigahertz. So eventually, your task processing speed is 4 gigahertz, isn't it? Or maybe octa core. So instead of 2 gigahertz single core, you are having 8 cores of 2 gigahertz running at each. So eventually, the processing speed is 16 gigahertz. So that is as good as having a high speed single core CPU, isn't it? So that's a better way of doing it these days. So no one, designers, they are seriously looking at this. Okay, let's design something which can run at 4 gigahertz or 5 gigahertz. No, they're not trying to waste their precious time on this. Okay, they are quite wise on this. Okay, so we move to the next stage. About this is about the software, but I believe I can skip this part because okay, maybe yes, no. Okay. I believe everyone. This is, I keep it for students who wants to talk about how the EDA tool started, and like how they have progressed and how they have changed our lifestyle. So we are, but I believe you are all from engineering background at the higher level, 7th, 8th semester, 6th semester. So you guys are familiar because you have been using computers and software for a long time. So these days, everything designs we do on the software, which are called as electronic design automation tools, or CAD tools. Okay, so computer designing is much more easier these days because you can always reuse the design, and you can always reuse. Sorry, so you can always reuse the design. You can test and verify the design faster, and obviously you can always speed up the design process. So this is all possible with the software which we are making use today. Otherwise, manually this was not possible in today's time, at least. Okay. So we even make use of software tools in Vlsi domain also. Okay. So there are lots of tools available in the market, even for the Vlsi. There are numerous tools. There are numerous. Okay. But then the learning of the tool is mostly about practice and working with the tools, because you can't take any tablet which is available in the market. You just eat through it and learn about the software the next day, or maybe read a book and learn about, because you need to learn both, because you have to also learn the fundamentals of the subject, the theory of the semiconductor, analog circuits or digital logic, everything. You have to go through it and then switch on to learning of the software. And remember that I believe most of the softwares, they are self-assisted learned, because they are training courses available. The courses are being taught. Even if I'm teaching you Microwind software, but then I would be able to teach you only 10 or 20% of it. I won't be able to teach you everything out of it, isn't it? So most of the software learning is by self-assisted. That means you have to sit with the software, play around, make mistakes, or go through some tutorials and read the manuals and then learn about it. Okay, so this is how it is. Everyone learns it. So Micron is also one of the software which is used for Vlsi design. It is divided into two parts. One is the layout part. This is layout side, that what we saw yesterday, and this is at the schematic side. Okay, DSCH. Both have some features, etc., which I will keep on explaining stage by stage as we pass through. Okay, and This is about the design flow of the Microwind software. And more or less, it's the same as what we have seen the ASIC design flow. But I will come back maybe tomorrow or whenever the time required in the next class. Okay, because I see the time now and I see that it looks like I went too slow, or probably I was sleeping in between, and we have hardly half an hour left for the hands-on. Okay. So there are a couple of books which have been written on this book. One is the basics of Cmos cell design, which talks about basic circuits, and the advanced one talks about some advanced circuits and their functioning, their some designs, and some examples are also available with these books. Okay, they are really very good and very popular in the academic section. Okay, there have been a couple of chips which have been also fabricated using Microwind software. There are not many, but definitely a few of them which have been successfully manufactured and they work really nicely. Okay, so there are some pictures of those manufactured chips which have been something to talk about the education side. So that I just shut down my video for a while. So the industry is moving at Moore's law. That is, every 1.5 to 2 years, there's a change of technology and a lot of new concepts and things, stuffs are coming in the market. Like these days, it is all about FinFET, and in the coming couple of years, we'll have multi-bridge gates. So things are about to change. But education sector, they are still lagging around, and we are still talking about CMOS. And even though the pace of teaching the subject is quite slower in the semester-based curriculum. And also, I believe you guys are also in the semester system in which the subject has to be covered, I'm saying, in 6 months of semester, out of which you get hardly practically 3 to 4 months. And out of that also you get only 2 hours per week lab, and sometimes you miss them. So the learning of the software tools is very difficult in the given time frame. Okay, so you need more faster design practice than you see learning about of the product. Okay, that's why Microwind comes into the picture, because complex tools are for complex design and they are very difficult to learn and adapt, and they have a very large learning curve. Okay, so Microwind offers you very ease of learning. You can focus more on design rather than learning the tool. That's very important. Okay, that's why Microwind is very popular and very popularly used by the students and the teachers and faculties across Indian side and also on the worldwide level. Okay. So with Microwind, you can put more focus and emphasis on learning rather than learning the software. Okay, it's about, you want to go to a driving school, and you always see driving school, they teach you how to drive a car. You never saw a car school where you learn about only the car. Okay, that this is a Ferrari school where they teach you how to know about the Ferrari car. They are all the same, because finally they are all cars with a steering wheel and brake, accelerator and paddle. So everything is same. So only you have to focus on learning the driving skills, not the car skills, isn't it? Car skills you may learn in 10 minutes, okay, or maybe few days. So don't waste your critical time during a learning period, because while learning a car driving, it's better to have a Maruti or a small car which is comfortable to use. On the first day, if I give you a Lamborghini and if you're not familiar with the car driving, so you can imagine what will happen to that luxurious car. Okay. Okay, so let's get on to hands-on and talk about it. Aradhya sir, you there? Aradhya sir? Come in, Aradhya sir. Hello, Aradhya sir. I call him. Don't worry. Tango Charlie 2 Alpha. Hello. Sir, you wish to restart the session?